we'll be looking at half-life from radioactivity. First and foremost, what is half-life? As the name implies, half-life. It is just the time taken for half of the total mass of the radioactive element to decay. Yeah, that is the time taken for half of the mass of the radioactive isotope to disintegrate or to decay. That is what we mean by half-life. And this is the formula here. The formula we have, half-life is equals to 0.693 divided by this lambda. This lambda you are seeing here means decay constant. So it is decay constant. That is what it means. So you should not forget this formula for any exam you want to write. Okay, we come to this thing you are seeing RF. It means remaining fraction. If they are asking for remaining fraction, fraction is something over another thing. So it is 1 over 2 raised power n. Now, how are we going to get our n? Our n is simple. Our n is total time taken divided by the half-life. For instance, if they tell you that an isotope has a half-life of 5 days and it takes 50 days to complete, what are we going to do? We're just going to do 50 divided by 5. Then it will give us our answer here. That's what we are going to do. 50 divided by 5. It will give us our n. Or let me say that it has a half-life of 2 and the total days taken is 6. What are we going to do? Just 6 divided by 2. Yeah, that will give us our n. That is how it is. Now, this one you're seeing here is remaining mass. When it is mass, it's still the same thing with remaining fraction. Yes, but this one now we have mass here. It's still the same. They can still give you mass and say you calculate the remaining fraction. So it's just simple. You have your initial mass divided by 2 raised power n. Good. Now, since we have seen how to get our remaining mass, remaining fraction, what of the decay fraction, the one that is no more there? How are we going to do it? We'll just do 1 minus the remaining fraction. That's how we are going to do it and get the decayed fraction. So without wasting much of your time, let's go into question. Let's go to the first question. The first question we have here to be displayed on your screen. It said the decay rate constant of a hydrogen peroxide is 6.5. That is, your lambda is 6.50 times 10 raised power minus 4. This is what we have. Now they said we should calculate our decay, our time, our half-life. That's what they say we should calculate. Now you remember that our half-life is equals to 0.693 divided by this, and we have it here 6.50 times 10 raised power minus 4. See what we are going to do? Okay. Now, when this comes up from your indices told you that when you bring something down that have a negative sign, when it come up, the sign will change. Definitely, if the sign is in the power. So if you are to solve, we have 0.693 times 10 raised power 4. This is what we are going to have divided by 6.50. Okay, if we solve further, we are going to have 6 points. Okay, let's do it like this: 6.93 times 10 raised power 3 divided by 6.50. Now, if you press it in your calculator, this divided by this, it will give you 1.1. So definitely, we are going to have 1.1 times 10 raised power 3, and that will be our answer. You understand? That will be our answer. That is in seconds. Okay, proceeding again to question 2, we'll solve question 2. If you go to question 2 says if 256 gram of radioactive isotope, it said if 256 gram of radioactive isotope. Okay, let's go to question 2. Question 2 now. So question 2 here is telling us if 256 gram, that is the initial mass is 256 gram. Okay. What else are we given? We are given the half-life to be 5 days and the days remaining to be this. Then we are calculating for the remaining. Okay. They said if it is 2/5 of a radioactive isotope whose half-life is this initially present. Say what fraction of it will remain? Good. What fraction of it will remain? The half-life, the T is equals to 5 days. Then the big T is equals to 20 days. They are asking us for remaining mass. What fraction of it will remain? Okay. Now we have gotten it here. We have the formula here already. So what are we going to do? To get our n, you do big T divided by small t. That will be 20 divided by 5 to give us 4 days. Good. So since we have gotten it, let's now come back to the formula. We have remaining mass is equals to initial mass. We have 256 divided by 2 raised power n. The n now is 4. Here we have 256. Now what is 2 raised power 4? We will be having 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times this is 8, this times this is 16. Then 256 divided by 16 will also give us 16 gram, and that is the answer. You can attempt many other questions. Anyone you cannot solve, send it